Okay, folks, we're going to move to 9.4. And 9.4 is dealing with combining operations, specifically with binomials. Now, the title combining operations means that we're going to be multiplying a bit. We might be doing some adding. We might be doing subtracting. But all of these examples that we're going to be looking at in 9.4 are primarily going to be dealing with binomials. And we're going to start with problem number 1. The directions says, perform the operations and simplify. An operation means we're either going to multiply, divide, add, subtract. And what we definitely have to do on number 1, and I hope that it would be obvious to all of you, it certainly appears that this 7 is a distributor, and this 7 is going to have to distribute over to each of the terms inside the parenthesis. And we have a binomial right here. Now, before we just jump right into the distributive property, if one wanted to do the following, one could take this radical of 75 and simplify it first. But I don't believe I would do that in this case, because the distributor on the outside is not a radical, it's just a real number. So we're going to start by just distributing. Clear the parentheses. 7 times root 3, 7 times root 3, positive times negative, negative 7 root 75. Now we're going to see if we can simplify. We've cleared the parentheses, but we're not done, because the radical of 75 can be further simplified because it contains a perfect square factor. So we're going to bring down 7 root 3 minus 7, and now we're going to get the structure set up to split up that radical of 75. 75 doesn't have a 2, but it does have a 3. And it'll go into 75 25 times, and then we'll have 5 5. We have 2 of a kind on the 5s. 5 times 5 is 25. That will go in the rational. And that little prime factor of 3 goes in the irrational. Now let's come back down. 7 root 3. Carefully. Negative 7 times 5 times root 3. 7 root 3 negative 35 root 3. Now we can subtract, because we have like radicals, same index, same radicand. Combine the positive 7 with the negative 35. That should give us a negative 28 root 3, and he's done. Let's see if I can just kind of leave that there, and let's move on to number 2. Let's see if we can't get this. This time the distributor is a radical, but it's not a radical that's going to cause us maybe to do any simplifying inside the parenthesis first. Let's just outright distribute. Radical of r times radical of r. Radical of r squared plus radical of r times radical of 72t. Multiply those radicals together to get a single radical, the square root of 72rt, or 72tr. He's a perfect square. He's rational. We'll write the rational. R plus 72rt. The rt, that's not a perfect square, but within 72, there is. So we're going to have to split it up. 72 to 36. I'll keep going. 2, 18. 2, 9, 3, 3. Very carefully here now. Here's 2 of a kind. And here's 2 of a kind. Let me do just a little bit of multiplying. Might save us a little bit of time. That pair of 2's gives us 4. The product of these 2 3's will give 9. 4 times 9, 36. 36, the largest perfect square factor of 72. That little leftover 2, irrational, along with RT. R plus, he comes out, plus 6 times the radical of 2RT. Can't do anything more. We don't have like radicals in order to add. It stays that way. That's distributing. Now as we go to problem number 3, we're looking at another form of multiplication problem dealing with binomials. And it'll be obvious when you see it. 10 plus root 6 multiplied by 8 plus root 6. We're multiplying 2 binomials. You've already probably said that word. So let's FOIL. Multiply the first terms. 10, 8, 80. Go to the outer. Outer, outer. They're both positive. Positive 10 root 6. Inner. That's positive. 8's positive. Positive 8 root 6. And then the last. Positive root 6 times positive root 6. One radical, positive root 36. Now let's carefully begin the simplifying process. Bring him down. These 2 fellas right here, the outer and the inner product, they can be combined because we have like radicals. So add that 10 with that 8 and we'll have positive 18 root 6. Bring down this plus sign. That represents the rational number 6. We write the rational number 6. And now combine like terms. 80, the real number. Positive 6, the real number. Like terms, combine them. Don't combine with that 18, because that 18 is glued to that radical of 6. He's a completely different term than those. So 86 plus 18 root 6, done. And by the way, you are looking at a binomial here. You are not obligated to have to factor out the GCF. For example, when you look at the 86 and you look at the 18, they both appear to have a 2. You do not have to factor out that 2. It's left in that way. We're multiplying. Good. Let's do another FOIL, so you'll have 2 in the books. Number 4. The quantity of 6 root 7 plus root 5. Close it off. Multiplied by root 7 minus 9 root 5. Binomial times binomial. FOIL. First terms. Be careful. First term, first term. 6 multiplied by the root. 7 times 7 times the root, 49. Let's go outer. Outer, outer. Positive times negative. Negative. 6 times 9, negative 54, root 7 times 5, root 35. Let's go to the inner. Positive times positive, positive, root 35. And then the last. Positive root 5 multiplied by negative 9 root 5. Positive times negative, negative 9 root 25. Back to the left. Slow down. 6 times, he represents a rational, 7. These two fellows. You're not always going to have like radicals, but the outer and the inner gave them to you again. They're like radicals. You have a negative 54 here. You actually have a positive 1 right there. Negative 54 coupled with positive 1. Negative 53 root 35. Negative 9 times 5. 6 times 7, 42. Negative 53 root 35, negative 45. Well, the positive 42 can be combined with the negative 45, and that would give us negative 3, negative 53 root 35, done. That's FOIL. And now we'll go to a third operation, a third situation dealing with binomials. And you'll see it. Number 5, the quantity of 2 root 3 minus 9, that quantity squared. We're squaring a binomial. Now, I decided going into this, I'm not going to illustrate the technique of squaring a binomial here when we're working with radicals. I think it will harm more than help. We're going to do it in the more simplistic way, the more understandable way. That exponent of 2 indicates that you have 2 factors of this binomial. So we're going to expand it out and write out 2 side by side of that binomial. 2 root 3 minus 9 times another one. 2 root 3 minus 9. Now let's FOIL. It'll be more secure. First terms. 4 root 9 outer Positive times negative. Negative 9 times 2, negative 18 root 3. Inner, that's negative 18 root 3. And then the last, positive 81. 4 times the root of 9, 3. Those puppies are like a negative 18 coupled with another negative 18, a negative 36, root 3, positive 81. 12 minus 36, root 3, plus 81. Add the positive 12 with the 81, should give us 93, negative 36, root 3, done. I believe it's the more secure way. We'll do one more of these. Call it number 6. The quantity, the radical of h plus the radical of 10, that's squared. Write it twice. The radical of h plus root 10 times the quantity of the radical of h plus root 10. First terms, radical of h squared. Outer, they're both positive. Positive root 10h plus, same thing, plus radical of 10h. And then last, plus radical of 10 times radical of 10 plus radical 100. He represents a rational. It's root. These are like. We can add them. They're like. You've got one there, and you got another one there. So plus 2 root 10h plus, that represents the rational number of 10. You can just leave it in this way if you want to. You can't combine the h with the 10. You can't combine those two because he's a radical and he's not. You can leave it that way. If you want to put h plus 10 plus 2 root 10h, that's fine as well. That's commutative. Either one of them, take it to the bank. That's done. And then one last form, and this will take care of 9-4. And it's kind of a key one because it's going to be dealt with in the next section. Number 7. The quantity of 5 minus root 7 times the quantity of 5 plus root 7. People back, I believe it was chapter 5, we did this kind of a multiplication layout, and they were called conjugates. Conjugates are two binomials that only differ in the signs between them. Everything else is the same. The first terms are the same. The last terms are the same. They only differ in the signs between them. And as you might remember, when we multiply conjugates, you don't have to do the entire FOIL process. You don't have to multiply the outer and the inner because they're going to cancel out. Now I'll show it to you here. I'll do the entire FOIL. Multiply the first terms, 25. Let's do the outer. That's a positive times a positive. That's plus 5 root 7. Let's do the inner. That's a negative times a positive. That's negative 5 root 7. And then plus the last, not plus. That's negative times positive. That would be negative root 49. Bring down the 25. Positive 5 root 7 combined with a negative 5 root 7. Add the positive 5 with the negative 5. You'll get 0 root 7, and 0 times anything is 0, so they cancel out. And you're left with negative 7. And 25 minus 7 will get it down to 18. I'd like you to add a little note to problem number 7. It's going to be key as we move in to the next section. Rule: whenever you multiply conjugates together, your final answer will always represent a real number. You'll always get a real number. You will never be left with any radical in your answer. No radical. You'll always get a real number. That's going to be key. Conjugates are going to play a key role in the next section. One more and we'll put a close. Number 8. The quantity of the radical of p plus the radical of q multiplied by the radical of p minus the radical of q. Now this time, they're conjugates. I'm not doing the outer and the inner because they're going to go. The first terms. Radical of p squared. Last terms. Positive times negative, negative radical of q squared. Notice he's coming out of the house, and he's coming out of the house, and we'll simply have p minus q. No radical in the answer. Represents real numbers. Now that takes care of 9-4. We will come back and do a little bit extra in 9-5. If you recall, we were already visiting 9.5 in a prior video. We're going to return to 9.5 and do more rationalizing of denominators, but this time with binomials. See you in a bit.